All right, hey guys, this is David. I'm one of the tutors for 61B, and I'll be walking you through problem 3 of worksheet 8 on the tutoring small sections. So let's go over this. They're asking us to implement a stack's pop and push methods using two queues. So first thing, let's kind of go over what a stack's pop and push methods look like in the first place. So I like to think of a stack in terms of like a stack of pancakes or a stack of books, something you'd see in real life. So if we call push 1, then push 2, then push 3, then push 4 in that order, um, what this will sort of look like visually is first we push 1, so it's going to go on the bottom of the stack. Then we push 2, which goes on top of 1, 3 goes on top of 2, 4 goes on top of 3, and you can see these numbers kind of stack up, hence the name. So because a stack is what's called last in, first out, it has this property last in, first out. What this means is the last item that we add to the stack will be the first one that comes out. So in other words, if we call pop, what we're going to do is we're going to look at the top element in the stack, which was the last one we added. We're going to remove it and return it. So if I call pop again, I'll look at the top element, which is 3. I'll remove it and return it. Cool. And now we can contrast this with the queue, which is instead first in, first out. Right. So if I add the items 1, 2, 3, 4 into a queue, you can think of this as like a grocery line. What this will look like is 1 comes in first, then 2, then 3, and then 4. And just like any line at a grocery store or an amusement park, if I want to remove people from it, I need to process them by the first person, right? So it's first in, first out. If I want to remove something from this queue, I must remove the first thing that we added into this queue. So the problem at hand here is that we have queues, which are first in, first out, but we want to implement a stack, which is last in, first out, right? So somehow we want to use structures that are first in, first out to do almost the exact opposite behavior, which is implement a stack that's last in, first out. So how do we do this? Well, I don't know about you guys, but when I first did this problem, I had no idea what I was going to use the second queue for. And when that usually happens, a good idea is to just see how far you can get with one queue. So let's do that with just Q1 for now. So let's say I have Q1, and going to this same example, let's say I push the items 1, 2, 3, 4 in that order. So somehow I have to store this data in, well, I only have one queue right now, so I might as well enqueue it, right? So let's enqueue 1, 2, 3, and 4. Cool. Now let's say I call pop. Well, the problem here is that somehow I want to remove this 4 and return it, but because queues are first in, first out, I can only dequeue the first item, which is 1. So how are we going to get to this 4? One thing we can do is we can dequeue all the items before it, then dequeue 4, and return it. And so far this looks good, but if we call pop a second time, then we're kind of screwed because what we just did is, well, we threw away all these items before the 4. This pop should return a 3. We have no 3 because we just threw it away when we dequeued it. So maybe here would be a good point to introduce the second queue, right? Because the problem we had was we sort of just threw away all these items. Maybe we should store them so that if we call pop again, we can get what we want, which is 3. So let's do that. Instead of dequeuing these items and throwing them away, on our first call to pop, what we're going to do is we're going to put them into the second queue. So we're going to dequeue this 1, enqueue it into Q2, dequeue this 2, enqueue it into Q2, same thing with the 3. Then we dequeue 4 and we return that. Cool. So let's say we call pop a second time. Well, now we can look at Q2 and observe that this is almost the same situation we were just in. We want this 3, but we can only remove the first elements. So let's do the same thing, right? We will, now Q1 is empty because we just dequeued everything from the last pop. So we're going to dequeue 1, enqueue it into Q1, same thing with 2. And now we're going to dequeue 3 and return this. Okay, so now it looks like we have some sort of algorithm that works. Now let's try to generalize this specific example into code that will work for everything. So again, we decided that push would be the same thing as enqueue, right? When we push onto the stack, we're just enqueuing into Q1. So let's write that in code. We're just going to say q1.enqueue item. And now let's look at pop. So again, looking at our last example, what we did when we had our Q1 with the items 1, 2, 3, and 4 was that we took all the first 3 items and we put them into Q2. And what this kind of looks like in code is we can do this with iteration or a while loop. We can say while Q1 is not empty, is empty, we are going to enqueue into Q2 what we dequeue from Q1. Cool. Oh, sorry, this is a mistake. This should not be is empty. This should be, well, Q1.size is greater than 1. And this is because once the size of the queue reaches 1, we know we're at our last element. So once we're at our last element, we want to dequeue that. So we'll set it equal to some variable called result. And this looks good. We could just return result right now, but let's look a little bit ahead and let's say we call pop a second time. So if we call pop a second time, right, the first thing, or what the code already does right now is the first time we call pop, we're going to look at this while loop. It's going to take out all these items from Q1, put it into Q2, and it's going to set or dequeue this last item and set it equal to result. And if we just return result right now, well, we would get the right answer if we call pop just once. But if we call it a second time, this code is going to try to dequeue from Q1, which is now empty. So the solution to this would be to always make sure that Q1 points to the queue with data. And again, because Q1 and Q2 here are pointers, what we can do is we can swap the pointers after this operation. So over here, we can say we want to swap the pointers. And what this looks like visually with this example is we say, okay, we want to make sure Q1 always points to Q with data. So we say Q1 should point here, Q2 should always be empty, so it'll point here because Q1 is now empty. Okay, and what swapping looks like is we'll first set some temporary variable of type myIntQ. Let's call it t for now, and we'll set it equal to Q1. We'll say Q1 is equal to Q2 because we want Q1 to point to the queue with data, which Q2 now has. And we want Q2 to be what Q1 used to be, which is now empty. And once we have the swap operation done, we can now return the result. All right, so now we have one working implementation. There's actually another solution to this, which is if you look at this code, notice that our push is very cheap, right? It only requires one operation, which is enqueue, while our pop is very expensive, right? It requires iteration. So we can do the opposite. We can make push expensive and pop cheap. And how are we going to do that? Well, again, let's designate Q1 as the queue with all the data in it, and Q2 as the queue that is normally empty. So if we want Q1 to be the one with all the data, then when we call pop, we want to just be able to call Q1.dequeue. And if we want to just be able to call Q1.dequeue, then somehow the last item that we add to the stack has to be at the front of Q1. So if I have the numbers 1, 2, 3, 4 pushed onto the stack like before in this order, somehow 4 has to be at the very front of Q1. So let's think about how we're going to do this. So let's use this example where we're pushing the items 1, 2, 3, 4. So let's push 1. Well, I can add 1 to the beginning of Q1 because it's the first item, but it's also the last one. So if I just call Q1.dequeue, we should get the right answer for pop at least. So now let's say I push 2 onto this stack. Well, what I want is I want 2 to be in front of the 1 in Q1, but if I NQ it into Q1, I can only put it here, right? Which is not what we want. So maybe NQing the second item 2 into Q1 is not the best idea. Let's NQ it into Q2, like this. And now we can kind of look at this and be like, well, 2 seems like it's in a pretty good spot, right? It's at the beginning of some queue, which is kind of what we want, right? We want it to be at the beginning of some queue because it's the last item we added. So maybe it's a good idea to, like whenever we push an item, to put it into the empty queue, move all the items from the queue with the data to the end of the empty queue, and then swap the pointers. So what this will look like is, again, let's say we push 2, so we're here in the code. Put it into Q2, which is empty initially. Take all the items from Q1 and NQ it into Q2. So now Q1 is empty, Q2 has some good data, and we're going to swap the pointers because we want Q2 to always be pointing to the empty queue and Q1 to be pointing to data. So let's do another example with 3. Again, if we NQ3 into Q1, well, 3 is going to end up here, which is not what we want, right? We want 3 to be in the beginning over here. So let's NQ3 into the empty queue. And again, what we're going to do is we're going to take all the items from Q1, which has the data, and we're going to NQ it into Q2. Cool. And now that seems like it'll work, right? Forgot to swap the pointers at the very end of this. But it seems like this works, right? Because now we have 3, which is the last item we just added at the beginning of the queue. And now all we have to do when we call pop is DQ from Q1. So let's implement this in our code. Let me get rid of all of this for now, because it's kind of just in the way. So again, we want to make pop the cheap operation, right? And we designated Q1 as the queue with all the data. So what we're just going to do is we're going to say return Q1.DQ. Cool. And now let's generalize what we did with our push operations such that it works with all inputs. So what we did was we kind of did 3 steps. First thing we did is when we're pushing an item onto the stack, we're going to NQ it into Q2, which is empty. Next, we move data from Q1 to Q2. And third, we swap the pointers of Q1 and Q2. So let's put that into code, right? Step 1, NQ into Q2. So we can just write Q2.NQ item. Step 2, move data from Q1 to Q2. And we can do this with a while loop. We can say, while, let me zoom in a bit, Q1 is not empty. We're going to NQ into Q2 will be DQ Q1. Now step 3, swap the pointers. This is going to be exactly what we did before. We have some sort of temporary variable set it to Q1. We're going to make Q1 what Q2 was before, and then make Q2 what Q1 was before, which is the temporary variable. So cool. Now we have 2 working implementations for this pseudo stack, and one might ask, like, okay, which one's better? Now I would argue that the one where your pop operation is more costly is the better operation, or the better implementation. This is because whenever we have stacks, we're probably going to be using the push operation much more than the pop. Right? It's much more likely that you're going to be adding data to the stack than you are removing it. So we want pop to be, it would probably be better to make pop the costly operation because that's the one we're going to be using less. Some more food for thought, you can actually do this problem just using one queue, i.e. you can implement a stack using just one queue. So I'd think about it, think about how you would approach the problem because it'll help with like your understanding of first in, first out and last in, first out. And you can always look up the answer if you really wanted to. But yeah, one more last note to consider is that usually for a stack, whenever we do this pop method, we want to check first that the stack is not empty, and if it is, we usually throw an error. We didn't do that for this problem, but just as a side note, that's something you usually want to do when you're implementing a stack. Yeah, hopefully this was helpful to some degree. Jay will be walking you guys through question 4 of this worksheet.